Ni saya dah start recording tau. Kita buat pembincangan.
Okay. Ni banyak tau.
Itulah. Bagi saya baca sampai tengok atas.
Tadi je.
Macam tadi lah teori. Tengok ada teori, ada objektif, teori lagi. Procedure. Sampai equipment lah. Saya baca sampai equipment lah.
Okay.
Alright. Okay. Ready semua? Okay, bismillahirrahmanirrahim. Dah Izan ready Okay. Bismillahirrahmanirrahim. Assalamualaikum and a very good morning. Good morning, sorry. Good evening. So today I am with my two other friends are going to explain
our last lab report.
Yes, to present our last lab report for engineering mechanics. So our topic is potential and kinetic energy. So my name is Muhammad Aidil Iman bin Abdullah. I'm with my two friends, Kosigar and Ifzan. So now I'm going to present about this report. Sorry. Firstly, our objective is to study about the principle of potential energy and kinetic energy. Second is our theory. 2.1, the mechanical energy. Kosiga. The mechanical energy is equal to the work done on a body in altering either its position or its velocity. Number 2, 3 types of mechanical energy. There are potential energy, strain energy, and kinetic energy. Number 3, unit of energy is Newton meter Nm or Joule J. Number 4, potential energy. It is the energy processed by a body for doing works by virtue of its position. Kosiga, scroll down. Potential energy P dot E equals to M dot G dot H. Represents M is mass of the body, G is the gravity of acceleration 9.8 0.81 meter per second squared. H equals to distance through which the body falls. Number 5, strain energy. It is the potential energy stored by an elastic body when deformed. A compressed spring possesses this type of energy because it can do some work in recovering its original shape. Thus, if a compressed spring of stiffness Newton per unit deformation is deformed through a distance x by a load w. Then, scroll down. So, this is the strain energy formula. Strain energy equals to 1 over 2 W at Wx equals to 1 over 2 S times x squared, where W equals to Sx, W equals to load, S equals to spring stiffness, X equals to distance. Number 6, kinetic energy. It is the energy possessed by a body for doing work. Kinetic energy, K dot E, equals to 1 over 2 mv squared, where m equals to mass of the body, the v equals to velocity. By conservation of energy before equals to energy after. So this is the example of how to calculate the energy. Scroll down. Yes. Okay, this is the equipment that we use in this experiment. Number 1, we use potential energy and kinetic energy kit. The function, it can change from one to other using of the pendulum or flywheel. Next, we use ruler, a device which is used to measure length of different objects. Number 3, we use stopwatch. The function is, it is handheld timepiece designed to measure the amount of time that elapsed between its activation and deactivation. Consider. Okay. Number 4, we use weight. The slots allow them to be placed on weight hangers, which are lightweight platforms attached to a trim with a hook at the top and can increase or decrease the load. Number 5, and the last procedure, scroll down. Okay,
That's all.
the last equipment is hanger. Okay, that's all. Next, Kosiga will continue to present.
Okay. Can you hear me?
Yes, clear.
Okay.
Yes.
This is the procedure for the lab 4. Okay, first is the hanger with the weight was hang on potential energy and kicked energy kit. Secondly, the height of the hanger was set equal to the 51 centimeter from the table surface. Okay, thirdly, we have to do the hanger was released and the stopwatch was pushed same time until the weight reached the surface of the table. Okay. The so the sum of the laboratory's activities based on the activities based on the experiments that we done, and the result is, and we have done v equal to 2g3 to the h. So we have also calculate the mass, velocity, and potential energy and kinetic energy. So that the time per second and the velocity vu plus 80 minute per second, and potential energy m dot gh joule, and kinetic energy, and we also mentioned joule. So the first thing we have 50 gram, the weight is 50 gram, and 150. So and the 100 for the 100 gram is 66.12, and the 150 gram 52, 100 gram is 4110, and finally the 250 gram 360, and we also do the same process in the. So all this result done, we also do the graph, and this is the for the potential kinetic. Okay, in the graph we also add. Hello, is that there anyone?
Yes.
Okay, I'll continue to the graph and section. Okay, for the graph, the relationship between the potential energy and the kinetic energy is that potential energy is the stored within the object while the kinetic energy is energized. That is the motion. So the connection between the two is the potential energy transformed into the kinetic energy. So that this is can be seen when the weight is not it is potential, but the weight is released as it fall. It is because the motion and the potential energy into the kinetical energy. So this is a calculation that I've made for the motion and the mass. that from the graph, we also understand the relationship between the mass and the time when the gravity affect an object. So the space-time in the bin curved by the mass of the one within gravity. So that the object has to travel longer, which is take longer time, assuming there is only gravity acting on it, because the mass doesn't affect the speed of falling object. And this is the calculation that I've made on the second graph, and the answer is my negative 0.039. Okay, discussion. For the discussion section, Izan will.
Okay, now my part is to explain about discussion and conclusion. So the discussion in this experiment, based on the result, I need to change mass of weight into kilogram and calculate the average time for each weight and use the data record for finding velocity, potential energy and kinetic energy for every weight. It is known that potential energy is the energy that is stored within an object, while kinetic energy is the energy that is in motion. This shows that potential energy change into kinetic energy. Then I plot graph for potential energy versus kinetic energy and mass versus time graph. From the graph, I able to observe the relationship between the potential energy and kinetic energy and relation between mass and time. As the potential energy increase, the kinetic energy decrease. Then the graph is plot straight line by taking average point. For mass versus time graph, as the mass is increased, the time taken decrease. The more weight, the lesser time taken for weight reach the surface because of gravity acting on it. There are also got some error while conducting this experiment. Random error, for example, time taken by stopwatch is start early or stop late when the weight is touch the surface. For systematic error, equipment is not calibrated before conduct the experiment. The equipment was not used. The equipment was not used properly and used incorrectly. This make the experiment to have some error and vary the measurement and reading. To improve this experiment, for accurate result is use proper and functional equipments. Stopwatch should start zero. Take measurement of average mass of the weight to get accurate measurements. So next we move to conclusion. In conclusion, all the objective and understanding and learning about the principle of potential energy and kinetic energy has been achieved. We also learn in this experiment that to understand that potential energy contained in object, while kinetic energy pushes energy and that potential energy is converted into kinetic energy is interaction between them. In addition, we search and calculate result. We also establish two graphs which we are need to find the relationship between potential energy and kinetic energy. And second graph that we are need to find the relationship between mass and time. Finally, we are able to observe the principle of potential and kinetic energy through this experiment.
Okay, alright. That's all for our lab 4. And this is the reference that we are finding and searching for our contents. And that's all. Thank you.
Thank you.
Thank you.